Test, test. Welcome, welcome, welcome to the Programming Games Club. Today I'm going to look at modular programming requested by a viewer. They gave me some specifics in the request and I will try and hold to those specifics. Let's turn a programming computer on. They didn't specify which operating system, so I've got a computer here set up for programming. I'll switch that on and we'll use that. First rule of programming, use what you've already got set up. Don't keep wasting your time doing the setups. Have a computer set up that you're comfortable with the utilities and tools that you wish to use. So we'll see what we've got in a second or two. We're going to do example 1, the calculator, the base module of all programs. If this works, it does. Do I need to write anything for you? No, let's do it. I was asked not to, I think. What do we got in here? Can't get rid of that. I've got to move my coffee, it's in the way of the other mouse. Let's start getting ourselves set up, shall we? We're live. We've got a viewer. Hello, viewer. Yeah, that's you. Okay, I've got a mouse. That'll do. Well, there it goes. Modular programs. I remember I actually set this up. That was a good idea. The other day, didn't I? I think it was Saturday. 2 streams ago. And we've got Qt Creator. We have set up a console application. A Qt console application. So it's not got very much here. I did add C17 because I didn't know what language to use. Nobody's given me a different language to use, so I'll use C, I guess. We have a main program, and I was showing you how arguments could be placed through to the main. That should give me just a simple run through the program. There we go. So argument count is 0. That means there's 1 argument because computers count from 0. I know it's confusing people, but just remember that that's where all the bugs come from usually. All the errors come from is that one fact. That's the biggest programming hurdle you'll ever have to get over. Even I still forget after 40 years. Argument value, or what did we pass into the program? On this line here, this argument value, we passed in the command to run the program. I think we'll use that for today's thingy. There's no way of exiting the program, so we'll have to crash it. Control C, wrong keyboard. Oh, we've got a keyboard that swings round. Yay. Go me. Alright, let's get this set up here. It works, this keyboard works, so I've got the right keyboard. And it just says it's crashed. If you look at the application, program's crashed. Good, everything's working as intended. You'll hear that a lot from me. So this is what we're going to program. Now, if you were to be programming yourself, you'd probably be designing the program first, if you've got any sense, and you'd be designing which modules or what each module should do. Like you would have a UI module, you'd have many different modules. For games, you might have a platform module, a world module, a model loading module, things like that. We never did put that model loader in, did we? Into that code base. Oops. It's on the files. So it's already out there. Ow. Right, let's see if I can set this up so that we can use it. Alright, I've got a keyboard. Right, so a module. Let's make a module. I'm going to call it Module 1. You can call it anything you like. Sources. Add new. Why not? Choose. Class name. Module 1. Don't want anything out of here. We don't want any help from Qt. Well, we might do, but not a lot. We'll go with that. Looks good. Oh, I see. This has no repository. Okay. I doubt whether this code's going to be useful to anybody, so I'm not really that bothered. Right, Module 1, here we go. It's given me all of this stuff, so I didn't have to type it in myself. That's very nice. It's given me a class. I don't really want a class. Okay. Right, the first things that we need to know. 1. Header files are not compiled in whatever this language is. I think it's C++, C or C++. CPP files are compiled. What happens with the header file is that it gets copied and pasted at line 1. Sort of. That's the easiest way to think about it, I think. So we'll save these. Okay. Right, it's modular programming. How do you go about modular programming? You create a module. So no matter which language you choose to program in, you need to separate off or protect this code somehow. In C++, you use something called a class. But because I don't think that you will be programming in C++, I'm not going to. I'm going to take it one step back towards raw programming. So I'm going to use raw programming, I think, for this. So it's easier to convert into any other language. The closer you program to raw code, the easier it is to convert. That's the first thing. Hello, viewers. You're all popping in. You're allowed to chat. You're allowed to interrupt me and ask questions anytime you wish. If I am focused on something, you may have to wait for me to notice that you've typed. It's on a separate monitor, and it's not in my line of view. So I have to turn my head and read. So feel free to interact. It's a games club. That's what it's about. It's about the interaction. It's not about me watching me program. Okay, programming language, what can you do? How's about a namespace? What? Why is it doing that? This is available in all editors. Why are you telling me that, Qt creator? Was that legal? I don't like it. You'll find out that I have a way of displaying on screen my programs. I type them in a certain way. Everybody has their own signature way of typing their programs. It's your personal preference whether you want this bracket here or this bracket here. Modern editors will put the bracket there. I'm old-fashioned. There we go. Basic raw programming is functional. So let's have a function. Module 1. So to create a function, it is indicated by brackets, and we probably need I don't know what we're going to need, so I'm just going to call it void. I don't know. So how does this function work? The function has its output, its name, and its inputs. So it's got no inputs, it's got a name, and it's got no output. If I right click on that, I refactor and add its definition. That's interesting, it's put the example like that. I don't want it like that. So that's bad. So the editor tried, but for me it failed. So instead what I'm going to do is I'm going to copy that. All we do is take that off the end and add the brackets. That's it. That's your program. No instructions, but that's how you set up your module in raw format, or the rawest format that you can possibly set it up. And we're going to do a calculator. So we're going to need two values. We're going to do integers. You've got to start somewhere, I guess. So this module will ask for two integers. Okay. How do we get so? There we go. We're typing, we're programming, but we're programming in English. That's what it has to do. There you go. There's your three things. Ask for two integers is assign. Ask for the operation to perform is an assign. Display the result is the output. So we've got two assigns. We are going to need to make a decision. I'm going to call it a command, not a function. Because I don't know if I'm going to make it a function yet. Call the correct command for the operation. Okay, so we're now programming fully. So we've got assign, we've got the decision, and we need the loop. There you go, that's a full program that has every single operation that you can program on a computer. There's only three things you can program on a computer. Shouts out for Nicholas. Yeah, Worth. I think it's Worth. Thank you for that in script tech. Good to see you in chat. And you're welcome. Right, so we've programmed the module. We've done it in English. That's that. We can save all of that out now, can't we? And if you were watching yesterday, I was describing the process that you have to go through to find out how to start programming. And you start with an entry point. We're going to remove you. And I'm going to remove you. That's Qt stuff. Okay. Ascii. So if argc is greater than or equal to 1, do that. This program should do nothing. Just getting rid of any red bits down here. Okay, program does nothing. That's not the correct output. That's not what I've asked it to do. Is that the correct output? Make sure your logic's right. Correct. That's the correct output. That's what we should have. We shouldn't have any output. Let's just tidy this up. And let's note. And argv to check if any extra inputs have been used. That'll do. So we have our program, it works. I don't really think we need this, because we're not using it. And I want to use module 1. There we go. Module 1 is now available to us, as we can include it. That will tell the compiler to link up our module 1 in with this main entry point. So this is our entry point to the whole of the program. That is how the compiler works. So we can do that. This is the main entry point for our program. Where it starts. Execution, I think the word is. I don't like that word. I'm not a pacifist, but I still don't like the word. I wonder which programmer. It must have been one of the original programmers. Babbage? Was it you who used that word the first time? Don't know. The main entry point for our program is called main. Makes sense, so that's why they did it. They also gave us the facility to run our program specifying arguments. So we could, what is our program called? Modular programs. Okay. So we could run this by saying modular programs and then specify something, and we can show that. We can with this program currently, so let's do that. Let's go and have a look. So on Twitch, modular programs, but we need the build. So we need this one. This is where our modular programs is being compiled to. As you can see, it says zeros, ones, ones, and this is the binary stuff. That's not supposed to be binary, isn't that supposed to be assembler language? File cannot be binary. It is binary then. Yep, that's binary. Okay, fair enough. Just want you to know. So, our operating system has a command prompt. ls. We have modular programs in green, which means it can be executed. If we have a look under its permissions here, permissions, execute, allow executing file as program. It's been ticked. So we have that available to us. To execute it, we would press, or just type in the command. Modula. Okay, I'm going to have to type it in, am I? Programs. There you go, command not found, modular programs, because I didn't ask it to use this directory to run it in. So let's try that again and use this directory, which is // on Linux. And there you go, the program does nothing. Which is exactly what we've asked it to do, nothing. But let's make this a bit wider, shall we? So as you can see, we ran the program, it did nothing. But if we were to type in something like there you go, it did something. Interesting. So it did pick up that I typed this. Okay. What happens if I change that to a 1? And compile it. You make changes, you have to recompile. Let's try that again. Well, number 1 is hello. Interesting. So we can see that the word hello has been stored at location 1. I haven't programmed any of this. This is given to us by the raw language that I'm using. This is a given by C and C++. It's also a given in most languages, funnily enough. This is Unix. Yeah, I bet you never knew that. The first language of sorts to do this was called Unix. It was developed by the USA military for communications. And not just communications from person to person, but for communications from program to program. And that's why it was really invented, is so that each one of these commands could communicate with each other. Each program could tell another program to run and give that program some information to run with, like a file name of data, let's say. So it allows for information to be passed between programs. Imagine the power. Because prior to Unix, you couldn't do that. Unix was the cornerstone of modern computing, and every language that isn't assembly language or machine code is derived because of Unix. C and C++, C being the main language that all 90% of the other languages are designed upon. Or C is actually the language they wrote the other languages in. Things like Java and all your lovely modern languages, all the non-raw languages that you can use today to make it easier for yourself to program. And all of those languages have at the heart of them a way of talking to each other. I bet that's not the first thing they teach you when you're programming, but hey ho. So we know what this is now. These are arguments that are being passed in to our program at the main entry point and being stored in a block of memory. We'll call it a buffer if you wish. A block of memory like a list. Think of it as a list. So if I change this to a 2, you know what's going to happen now, don't you? Because it's a list. 0 was the command issued. One was hello. So 2 will be what? World. But there's a problem with our program. It's not very good. See? It didn't give us an error. We have just accessed a memory location that doesn't exist. This is why you need to be careful when you program raw code. This is why we have modern languages which wouldn't have done that. They would have gone error, 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 this doesn't exist. You've just violated accessing memory. You have a SIG fault. This is the definition of a SIG fault. You are trying to access memory which is not yours. Luckily, let's see if we can get the full SIG fault, shall we? We might be able to. Bum, 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 bum. Yeah, let's try it. I'm hoping we'll get an error message now, because we're not just going to the boundary of the memory area, we're going past it into memory that isn't ours anymore. It compiles, of course. It's a valid program, after all. There you go. There's your... whoa, hold on a minute. System D exec PID 824. That's an error. That error is SIG fault. Access of memory outside the boundaries of your program. That's the operating system trying to protect us, I guess. I'll do. Can I have the actual error, please, and not just these stupid things? It doesn't include 824, so I'm not looking at that one. Do we have a list of what 824 means? Description, template, default defense options. Oh, this is the manual for that. And do you tell us what these numbers mean? Is there a list of numbers? There is somewhere. I don't really care where. Oh, I mean, only yeah. So you'd need to look up the number. It's on the internet somewhere. I'm not doing it. Right. So now we know we can create errors in programs that we can compile. We can make a mess of programming. A serious mess. That's also interesting. But let's get on with our module. Just remember that even though you are learning to program, or you are an expert programmer, you are still probably going to make mistakes which aren't going to show up here. And you won't know that you've made the mistakes because whatever you are using, whichever tool you are using to program with, isn't going to pick it up. It isn't going to tell you. The errors will be in the usage of the program, not in the program or the programming of the program. And this is why we test our programs, to make sure that using them isn't going to cause our computer to crash. Luckily there was a protection on. The operating system protected us from the computer crashing, so we got lucky. Right, we can now call module 1. That's the one there. We protected it in a namespace called example. Let's go to module 1. Let's make it do something, otherwise we cannot see what's going on. Where did I put that .h? It matters. Main, please. Right, qdebug comes after module 1.h. Let's cut, because it won't work if we put it there. Okay, I want to use qdebug, so it has to be included before it is used. That makes sense. You can't use something that hasn't been included within your program. And remember, an include is just a copy and paste. So I can now use it. Q info. This is just the way I type it. You don't need to keep pressing return and putting it on separate lines. You can put it all on one line. The number of lines you cover doesn't matter. The end of the line is the semicolon. All of the white space is immaterial. Irrelevant. I set it out like this so that I can use it. It's now telling me that use of undeclared identifier QInfo. Now that's interesting because I just swapped them over. So it doesn't actually know. I'll put a \n at the beginning. That means new line. That's an embedded command. Running. We'll give it another new line. Make it look tidy. Put a semicolon on there. And compile. There you go. QInfo was not declared in this scope. A scope is these brackets. Which means that our compiler can't get there. It can't find QInfo. Even though it's in here. So what we have to do is repeat that. And we can repeat it in here. You see, it only looks to the header file. It doesn't look to main. Main does not belong to module 1. Only the header file. We don't include main. Main includes our module. Be careful with that. But there's a problem then. You're going to be copying and pasting this twice. Once here. Once here. Sorry, once here. To stop that, we have a guard. Something that says, no, only copy and paste once. Once you've copied and pasted this, Mr. Compiler, you cannot copy and paste it a second time. This will be a preprocessor directive. Oh, by the way, sorry, I forgot to show you it compiles now. And it runs. Module 1 running. There you go. That's what I've asked for. That's the information I wanted. But that copy and paste is very important. You forget this header guard, you're in trouble. This is the... I guess today it's very old-fashioned. And it can be replaced by... I suppose if you're using VS Code or whatever it is, Visual Studio, you probably do hash pragma once. That's the command that replaces 1, 2, 3 lines. These 3 lines are your header guard. That's a modern day way of putting it. Does exactly the same thing, functions exactly the same. It's the same code, but it's that hash, this pinkiness that I've got on the screen. It's color coded. It's called a preprocessor directive. That's its official title. What that means is it's an instruction to the compiler before it starts compiling your code. We are saying to our compiler that this file can only ever be included once. And if we go to qdebug, goes to here, let's follow. You'll see it's here as well. So this file can only ever be included once. It can only ever be copied once. All of this code. As it would be very, very inefficient if it was copied more than once, and plus the poor program would get very confused as which one of these it was supposed to go and execute if we asked it to run one of these commands in here, like stream, debug, qdebug, qinfo will be in here somewhere. You could look through it, you'll find it. Eventually hidden in amongst all the code. So that's what these little pinky bits are all about. These includes. They are a necessary part of the construction of this language for it to work, because the compiler has to decide which of these includes to use. It can only use one, and we have 2. We have 1 here on line 5. We have 1 here on line 4. The compiler is going to decide which of these 2 is the correct one to use, and every time we use qinfo, which is within that file, or the files that this file uses, or the files that this files uses, somewhere down in the depths of all the spaghetti, is this function, this module. The compiler is going to decide which of these includes takes priority. Once it's defined which one is the first one that is required, it will copy and paste all the information there, and qinfo, whenever it's used in the program, will then only go to that one version of qinfo. Okay, I think that was simple enough. Right, so module 1 is running. Let's put that in English then. I've missed a thing. Good. You've already completed your first program. Okay, module 1. Ask for 2 integers. In raw code, how do we do that? There must be a way of doing it. So, yeah, okay, we'll skip that for a second because I don't know. Ask for the operation to perform. I think that's the same as these 2. These two are going to be similar. Call the correct command for the operation. Okay, that's probably going to be if or switch, maybe. Something like that. That's going to be get from console, maybe. We haven't got a graphical user interface set up. Fair enough. Display the result. I can do that. The result is going to be a string. We'll need strings then, won't we? Do we have strings? That's just a GUI. We've got core. We've got Qt core at our disposal. Okay. So yes, we can have strings. There you go. We've got strings now. That was easy. I'm using Qt. Qt core. So anything that's in the Qt library that is available, like QString. Here's the class, QString. Here's all the information. This is what it can do. It can do an awful lot. These are all the functions that have been written for us. We don't have to program these. It's been done. So let's have our QString. I'm going to put all the variables at the top. It's an old standard. So we can have a QString. We can call it result. And that's a command. That's telling our program to create a memory location that is available to us to store data in, and it will be in the format of a QString. If I press F1 on QString, the format of the data will be given to us as char star string. Okay, so it's a const char star. That's what it converts to. Const char star is C. I can replace this with const star char. I don't need to include QString at all. But look at all that functionality it has. Something's just happened. It went from a colour red to this colour blue. And this has got a weird shade of purple, mauve. I don't know what colour to call that. Brown, maybe? I don't know. But these two are the same colour as well. And that's got an underline on it because it's an unused variable. We haven't used it. So it's telling us that we're wasting memory. Hey, thanks. We can stop that quite easily. There you go. But now it's telling us it's set but not used. Is never accessed. So let's display it. We can use QInfo, can't we? May as well use what we've already got. I'll put a \n in. Result equals result. let's make our result equal default. How's about that? And let's add an extra line here, just to keep the spacing on the screen going quite nicely. Okay. So we're expecting the result to be default. Fair enough. Compiler. And, as expected, result equals default. It's got 2 spaces here. I didn't ask for 2 spaces, did I? No. So this function has added a space. I didn't know it was going to do that. And that's the problem with using pre-written functions. Do you really know what they are doing? The answer is no, not unless you go and read them and understand them. The only way you're going to find out what they do otherwise is by reading the manual, if the manual actually tells you that space is added. All well and good. But if it doesn't, oh, well. The manual was written by the human being, probably, who wrote the function. Possibly. There's not very many guarantees here, is there? So we're using a little bit of guesswork in our programming, aren't we? Now our program will do what it's supposed to do and act as intended. We had to test our program to find out that this is the output that we should have had. But we didn't have that output. It's different. But it's only because I ran the program, I tested the program to see what the output was, and I instantly identified there was an extra space here that we hadn't asked for. That extra space is a memory location. Each one of these letters is a memory location. Each one of the whole thing, everything that is output to the screen here, is output of data held in a memory location. So we actually had in our program, can I actually highlight it? Yeah, I can. There you go. That white square there, we had a memory location in our program that we didn't know about. That's a security risk. Because we're not controlling that memory location. We didn't ask for it. And that's why I had to alter the program to give the correct result. We are in control of all of the other memory locations displayed on that line. On this line here, we are in control of every single memory location except for that one. It's not an error. Look, it's not an error. You haven't programmed badly. You just haven't been told the full information. So you're only ever going to get the full information if you test your program and find out exactly what the hell it's doing. You need to understand what your program is actually doing, not what you think it's doing. It's up to you. You don't have to. But it would help if you did. But now you can see the difference between pass 1 code and pass 2 code. There is a pass 3 code, which is the gold code, which is no errors, no bugs, no reliance on operating system. probably a bit more difficult to get to if this is your first program, so stay with pass 1 code if you wish. You can. Your program is not going to fail because of that. So pass 1 code is the stuff you type in. Pass 2 code is the code, the resulting code, after you tidy it all up and take out all of those errors. The ones that you can't see, not the ones you can see, not the errors that you know about, the errors you don't know about. That's pass 2 code. Gold code doesn't rely on the operating system. This code that I've written is actually gold code. It doesn't rely on the operating system. I can write this on Windows and it'll do the same. I can write it on the Mac. It'll do the same. Will it do exactly the same though? Will the operations and the machine code be exactly the same? That's the gold standard. That on each operating system, the machine code produced by compiling this code is exactly the same. And that's your gold standard. So, that was your introduction on how to construct a module, what pass 1, pass 2 and pass 3 code is, and the fact that it doesn't matter what you do as a programmer, you may lose control of memory somehow, especially in pass 1 code. You'll probably have no control of your memory, the memory of the machine, at pass 1. Pass 2 is usually about taking back control of that memory and making sure that you don't mess the computer's memory up so it can crash or interfere with other programs. If your program interferes with another program, that's called a bug. Bugs are unintended. And have no ownership. A bug cannot be owned by any one program because nobody knows who screwed up that piece of memory. The computer certainly doesn't. And you certainly, as the programmer of the thing that did it, you don't know either, so you don't have ownership. The program doesn't have ownership. A bug is not owned. An error is owned by the program that creates an error. But that isn't an error. That's a bug. An error can be detected, and let's say we have an error. This is an error. Watch. There you go. It's an error. Expected semicolon before A. And it will tell you where it is, everything. It'll tell you everything about the error. That is an error. We'll remove the error, shall we? An error is owned by the program in which the error is. It can be seen, it can be tracked, it can be corrected. You as the programmer and the program that you have written will own that error. You are accountable for errors. Errors have ownership. In industry, error-free programming is commonplace. It's pretty commonplace. But error-free programming is only pass 1. It's not pass 2. Pass 2, you need a bit more than that. And of course pass 3 is nigh on impossible. So just understand the terminology and don't get fooled by the people out there that says, when they see an error, they say, oh look, there's a bug. Let's correct it. No. If it's got a little red pling by it like this, it's an error. You programmed an error. Not a bug. Bugs aren't programmed. They exist. There we go, we can clear that off. Thank you, that works perfectly. Good. So, this language is changing, I believe, and the errors and bugs are now being placed together so that you can sweep the bugs under the carpet and ignore them, so that pass 2 does not have to be completed. Pass 3 is totally ignored in modern computing. Pass 3 is considered impossible, and yet in front of you is a program that is pass 3 compliant. So how do we program the rest of this? We have displayed the result. Oh, we've got that repeat to do, haven't we? Should we do the repeat? Well, the repeat's in the wrong place. We don't want to be repeating this within the module because we might want to have other modules to run as well. So why restrict ourselves to one module only? Let's not. So take it up to the program that was running it. We can use a scope here, couldn't we? But you don't see people program like this these days. Did you know you could do that? It won't repeat because I haven't told it to. So we're going to need a way of controlling this loop. Well, luckily the programming language lets us do that. Raw programming lets us do that. Well, actually, not every single language in existence lets you do that. There are some languages that don't. Which is interesting. So we're going to need a command of some kind, aren't we? How about that for a command? Oh, he's got those colours again. Blue. Blue means it's a raw command. These strangely coloured things mean it's a raw data type. Just realised we don't need QString at this point in time. We're including something we're not using. Don't do that. It's usually bad practice. You can do it. It doesn't really matter. If it's not being used, the compiler will say, hey, this isn't being used, and throw it away. Clever compiler. But there's a problem. We haven't got something called running. And I've called it true. So we'll need a data. Some kind of data. Storage, a memory location to store true or false, and we're going to call it running. This is where it gets interesting. If this line is executed, it will create a memory location and store the value true into that memory location. This doesn't exist, and it's not an error. Why isn't it an error? C17. 2017 version of the C language. That isn't an error. Oh dear. I wonder if it's Qt that's put that there. I don't think it's C17. I am going to look this one up because I'm interested. C programming language wiki. Here we go. So this will list all the versions of C, I hope. Second edition, okay. C programming language. Blah 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 blah. Where's the history? It's got influence, but they haven't got the history. That's interesting. Yeah, the history's at the top, is it? And that's it. Okay. We'll go to Ascii. Yes, this has got the list here. So in 1989, C was standardized, basically. A standardized C came about. In 1990, it was upgraded, or a new version came out. In 1995, when Windows came out, because of the way we were beginning to program, C was upgraded again. In 1999, it was upgraded again so it could cope better with the way we were programming. In 2011, the upgrade to the internet happened, and of course because of that, C had to be upgraded. In 2017, an upgrade to C was implemented, not just to standardize, but to correct the problems they made with C11. And C20X, or C2X, 2020 something, 21 is it? Yeah, is current version of C, which allows you to do a couple more things. You can look at the changes they made. So C90, C95, 99. So as of October 2018, the 2017 version of C became the current standard for the C programming language. C17 addresses defects in C11 without introducing new language features. So it was a bug fix. And that's why I'm using it. Wasn't an error fix, it was a bug fix. It gives us a better chance, doesn't it? But think about that. Hold on a minute. Does that mean the language has bugs? Yeah, of course it does. The language you're writing your program in, has bugs. Yikes. That's an eye-opener. Reference. Here we go. Let's see what we've got. Can we see what we've got? No. Right, the language itself. Oh, it didn't have any upgrades, did it? So we have to go back to C11 for the actual language, do we? Okay. Are you going to give us a language or not? Tells us what was added. Here we go. Here's your language, C11. So if we go down here, we should be able to find the actual language commands that we can use. Blah, 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 blah. This would probably be a good read, actually. Probably a bit convoluted. Oh, you're going to the standard changes. Alright, we're nearing the bottom anyway. La 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 la. Standard distributions, okay. That's from the libraries, that's from the things that they wrote to help you program. Prove C compatibility. Nice. So it doesn't tell us the commands. Interesting wikis, aren't they? So the language itself isn't at C11. It'll tell you the functionality improvements like new string literals and user-defined literals, but hey ho, garbage terms which confuse people. But the biggest one was multi-threading memory model, because that was the stage at which multi-threading became available. I'd advise you not to use it. It's bugged to hell. Library changes. Alright. So we're not going to get it at C11. So let's stop messing about and get back to C98, shall we? Let's go back to the earliest version. There you go. Int main, hello world. There's your hello world program. Criticism. Somebody criticise this? Really? Did you have to? Why didn't you just do better? This is the best we've got. So this tells you how it works. Oh, C doesn't have inheritance. Yes, it does. C doesn't have templates. Yes, it does. They're just very difficult to use. Technical report, blah, 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 concepts. I wonder if it's in the ISO. And we come back to where we started. Ah, there you go. This is the whole of the language for C. That's all you have to learn. If you want to program in C, you just have to learn that. It's not really got a big dictionary, has it? So, the ones in blue are the ones that we are seeing in a different colour. The ones that we are seeing in blue are in black here. So void should be blue. Yes, it is. Where's bool? That's been given by Qt. I thought it wasn't in there. There is no bool. There is no raw data type bool. In C99, they did introduce underscore bool because they realised they'd made a mistake by omitting it. But instead of rewriting it back into the programming language, they did this workaround. They added a new command. And because people were already using bool as a type, one of these blue things, they'd written their own. People had written their own already, because bool is obviously the most useful thing, and they forgot to include it in the language. Yikes. That they had to do this workaround. Because if they hadn't, all of the programs prior to 1999 would have stopped working. And that's why there's no bool in C. It's not because bool doesn't exist, you can program it. We're using this lot. But they forgot to do so. Bit of a big boo-boo, don't you think, for the fundamental programming language that we use today? Bit of a cock-up, really. And that's what they forgot. So that is Qt's version of bool, not raw bool. This again causes a problem, because unless I'd looked it up, I wouldn't have known that. You're learning to program for the very, very first time, and you don't realise that the programming languages that you are using, even though they have this in true or false, a bool can only have true or false. It has two values, it's binary. True being 1, false being 0. It might actually tell us if we hover over it, do you think? Yeah? No? Nope, it's not going to tell us. True is part of the language. Bool is not. That's a bit confusing, isn't it? So these types are data types. These blue bits are the actual language. These are the language commands that we can use. There's only 3 language commands, really. One of them is hidden. There. They programmed in all of the Boolean functionality, or did they? I can't remember. I'd have to find out. I don't think that's in the language. That's a language command, while. Something is true or false. That's a language command. That does exist. But it's a 1 or a 0. That's true. See? It compiles. Yes, there is a standard library function, so it's coming from the standard library. Okay, that's just told me, thank you. So true isn't in the C language, it's in the standard library. Okay. So they didn't do Boolean originally in C, and yet it is what all programs rely on. Bit of a cock-up. And we celebrate this as the father of all languages. Which it isn't, it's just about 80% of languages. But we say father of all languages to make it sound good. So what is this doing? What's this scope thingy? I think we'll have to explain what scope is now, because we keep using this bracket, and as you can see, watch what happens if I highlight one. It'll highlight its corresponding thing. Scope has two symbols. An open curly bracket and a closing curly bracket. Each scope has its brackets tied together. Anything that comes between those two brackets is in that scope. Whilst we're doing that, let's neaten this up. There we go. That looks a bit better. So while we're running, or running is true, we're now back to that same problem where there's no end. Running never becomes false. So to stop that from happening, we'll put a question mark at the end, and we'll type running equals false until we decide on the appropriate way to do that. And I usually do that as well. I always put an extra space in. The spaces don't matter, it's the semicolons that matter. Anything between the two semicolons is a command. So that's what the semicolons represent, the end of a command. What comes after that semicolon is the next command, until you run out of commands and the program finishes. So we can now run this. There you go. Gives us the correct result. So we don't have that many commands. We have 1, 2, 3. Everything else is a variation on that. That's how you program. If there are any other commands in the language, they're just variations upon those 3 commands. For instance, you could use do. This now becomes an error, but do is a command in raw programming. It's a command. It's got a semicolon at the end. You've just written the same program using the same language, but in 2 different ways. What's the difference? The difference is where this happens. This program works in exactly the same fashion. Gives us exactly the same result. So it doesn't really tell you what's going on, does it? Confusing as hell. This version checks whether running is true before executing what's in this scope. If you put do and then a while running equals true, then this is checked after running your scope for the first time. And that's why the two things exist, because the two things, even though they are the same commands and they produce the same machine code, it changes how it operates. If that isn't true, this will never exist. This is going to be interesting. I wonder what's going to happen. See? Watch. False. What's going to happen is the compiler will just remove that. So there's no point in doing it. You can't even see it happening. The compiler will look at this code and say, that's never going to execute, and throw it away. And you'll never know. These things you have to be careful about, because do you want whatever's in here to happen once and then check if it should happen, be repeated again? Or do you want it to check before running this code and only repeating if it continues to be true? Oh, there's another thing. I'll do this first, actually. There's two weird things here. That's one equals sign. Why is there two here? This is Boolean logical equals. This is Boolean maths. This is human maths. I think that's the best way of putting it. Bank details have come through. Thank you. You are a star. I've got to reply to this. Oh. Cheers. I'll sort the payment. There you go. Done. Remember, doesn't matter. Don't deviate. I'm not supposed to deviate. So I did have to reply to that immediately. Right. So we've got computer maths and the maths that you were taught in school. The maths you taught in school has plus, minus, divide, multiplication, and equals signs. This doesn't. This mathematics has weird symbols for equal to, not equal to, and, or, Boolean maths. It's all truth tables and logic. It's a completely different kettle of fish. Don't get the two confused. Can be awkward if you do. Scope. How do we explain scope? These brackets. Scope is used to protect memory. That's all it does. It will modularize the memory. And that's pretty damn useful because we're using modular programming. Some people might call it functional programming. or mistake it for, but it isn't. Modular programming is not functional programming. Functional programming is a part of modular programming. That's the difference. Apples are part of the fruit family, but all fruit is not an apple. Make that distinction. This is why I say we have to program in modules, because we are already doing so. You don't get a choice in the matter. You've got these brackets. Quite a few programming languages do use these brackets. It seems to be a standard across quite a lot of the modern languages that we use. And it's probably a good standard to have if people understand it. But when you get taught programming, or somebody teaches you to program, one of the things they say is that this is the beginning of a function and this is the end of a function. No, it isn't. It's a scope. This is a memory address where the code begins, where this happens, where the instructions, the commands, the binary starts in memory. This is the end address in memory for where these commands happen. This different scope here that I've put in can be anywhere else in memory. It's modular. The commands aren't running down here anymore in a list. They're running down in a list to this point here. Line 21. And then they go somewhere else in memory. And then they come back out to this memory at line 29. And we can add more instructions. And at the end of it, it goes back to the operating system and closes the program. Interestingly, every time you come to this, it does the same action. It returns to the previous part of the program, or the previous memory area, and deletes this. Is that variable here that we have defined the same as that variable there? No, it's not. It's in a different memory location. There is two copies of this variable. There's one in this scope and there's one in this scope. Because we haven't defined it in this scope, it will use whatever value it is in this scope when it comes here. Watch. Doesn't matter where I put it. No, I won't do it that way. Should do. You should always put them at the start. It's good practice to put them at the start. But if I tell it to use a different memory location, it's an unused variable. It's a totally different variable. Just because it's named the same to us, human beings reading the code, it's a different memory address. It's not the same as this one here. Because if you did that, you would think, oh, it goes back to the top and checks running again. No, it doesn't. does it? Gotcha. But we can still use the original memory address. It can be, or the original, it's actually a pointer through to the memory address. That's what happens, the pointer gets passed through, but that's beside the point. We're not doing pointers right now. We're using them, but we're not doing them. We have a pointer here. And we have another pointer here. We're using them, but we're not describing them at this point in time. I'm trying to get this scope over to you because it's very important. So you could make an error in the logic of your programming. Not in the programming itself, but in the way the programming actually executes or runs. You could make it so your program runs differently. Just with one word. Just by telling it that, hey, I want to use the same variable name again. That's dangerous. Try not to do it. If you are using that name, make sure it's from the previous scope. And if there isn't a previous scope, define it there. Just a handy hint. Otherwise you're going to confuse yourself and your programs are going to probably be bad. Okay, it's still got that up. It's still telling me the wrong thing, so let's clear that, please. Thank you. Done. See, I have to compile it to let it know that I've corrected it. Interesting. And that's why Qt Creator works and Visual Studio doesn't work. Visual Studio tries to do it on the fly and gets it wrong. Shame. Sorry, Visual Studio, to just let you know your problem. But Microsoft didn't quite get the programming right. IntelliSense, they call it. IntelliStupidity, they should have called it. I digress. Sorry. So we have an idea now that scope exists, but if I put bool there, running equals false, it becomes a new variable in a different memory location. When it hits this and returns to the original scope, that can no longer exist. It's wiped clean. It has to be wiped clean. It dies. The variable will die. Otherwise, the two memory locations would pollute each other. And the terminology is memory pollution. To avoid that, the memory is wiped clean. And the same happens here. The memory is wiped clean, the memory is handed back to the operating system so that it can be applied to other programs or other commands. You'll have heard of something called memory leaks. That's when that doesn't exactly work out. And those closing brackets don't quite do the trick. They try the damnedest. But they don't always work. And that brings us on to pointers, obviously. Which you don't need to know about. Pointers are irrelevant. There's no such thing in programming. Pointers point to a memory location. It's a term. It's a fictional piece of dictionary language rubbish. They don't exist. And yet, it's the biggest headache of every programmer. In fact, some programming languages go so far to protect the programmer that they have systems called garbage collections, which will take the pointers that aren't being used and delete them, freeing the memory back up to the operating system before anything nasty can happen and your program pollutes another program. That's what happens when you have a memory leak. You cause a bug. That's where bugs come from. This has been around since 1980 what? And that closing bracket doesn't work? WTF? "40 years. Well, it will be in 36 years, we'll call it. Let's get more accurate. 36 years, and they still haven't solved the problem of the closing bracket. And because 80% of other languages were written using this raw language that I'm using here to program, all of those languages have the same bug generating capability. It's not a bug. The closing bracket works perfectly well. There's no error there, and that's why they can't fix it. That's what yesterday's experiment was about, by the way. The reason why I wanted to do it. I think this is why. It's that closing bracket. Yesterday I did a talk on where do you start programming. Today is the practical. But after the talk yesterday I did an experiment which lasted 3 hours to prove that last final bracket there on line 30 is correct and has been programmed correctly. Yet it doesn't quite work for some reason. It's where the bugs come from. Programs are starting up and shutting down on your computer all the time. That closing bracket is in operation quite a lot. Memory is being defined and destroyed at unbelievable speeds on your computer, even as that cursor flashes. And I don't touch the keyboard. It's happening now. Windows 11 has over 1,000 programs running on it at any one point in time, all written in a language based on this, with closing brackets. All of those programs are creating and destroying memory buffers all the time. A buffer being a storage area for data, which is what memory does. We call it a buffer when we define it, what the memory location is, where the memory location is, and what the memory location can hold, the type of information that it should hold. That's then called a buffer. So if this is happening all the time, bugs are being created all the time, memory is being messed up, messed around, never cleaned. It's the cleaning of the memory. It's the resetting of the memory location that doesn't happen. The value false will still be in the memory location even after this. But it's a 0. Is that a problem? What should you reset the memory location to? 0? Is this self-cleaning code? Well, no, it shouldn't be a 0 and it shouldn't be a 1. And that's why computers have bugs. It shouldn't be a value. If the memory location is out of use, it should not be holding a value. It should be switched off. But we don't do that, do we, computer? The memory is plugged in. It's got electricity going through it and no switches. Well, it's got tons of switches. It's called Boolean logic. But there isn't. There's only 2 states in Boolean logic. There's only 0s and 1s. There isn't an on and off. There isn't the third state. The rule of 3. So you're going to write a program and it's going to have bugs. Okay, let's accept that. You'll never get to pass 3, gold standard, if you think that way. Let's write the code. What's a good way of getting 2 integers? Cin, console input. We could use that. That's in the standard library. The answer is you can't. There isn't. In raw language, there is no command to get input from the console. Maybe that was a mistake as well that they made. Yeah, there's no way of doing it. So we can't get the inputs. We can't get the operation, therefore. We therefore can't do this. But we can still display the result. And there you go. That's your program. It needs probably developing because you can't do what you want to do. There are an infinite number of variations, solutions to this problem. No one solution is correct or incorrect. And that's why you need to learn to program. It's not about the brackets. It's not about these commands. I'm using a third-party command here. It's in pink. That means it's third-party. It's been given to us by the Qt library, not the standard library, but the Qt library. I've done that just for ease, because I knew that the command didn't exist. So I've cheated a little so that we could have some output. So we can't actually display the result either. There's no way in the language to do that. So who wrote this function and how does it work? It's a message logger. Yeah, I know it's a message logger. Thank you very much. It comes from QMessageLogger, does it? I didn't know that. So we've written module 1. We can't write anymore. We've now got the gold code. We can't program this module anymore without specifically knowing what these things are. So this is where programming starts separating down into modules. This is where you start programming. Instead of calling it a module, though, we'll probably give it a name. Let's try ask for integer input. We don't have a basic value, but we would have an integer first. Integer. We would then have the next line would be integer. Second integer equals, guess what? Oh, we've got those red marks again. Use of undeclared what? Use of undeclared identifier. Ask for integer input. Okay. So it returns an integer. So there's the return value. Has to be exact. It doesn't have any inputs. We can put it in the same namespace because it's still part of the example. But it's not in the same scope. Can you see the problem about the scope? Non-void function does not return a value. Does now. I'm filling in the code, but have you noticed I'm not using raw programming language? There is another one of them. There's another blue one here. We return the integer. The integer in this case is 0. So we haven't done what we've said we're going to do, but we are at least complying with the language. Ask for operation. Now the operation isn't an integer, is it? It's a character, it's a plus, it's an equals, it's a whatever. So it's a char star. Don't put spaces in, it doesn't work. I'm not going to be putting operation to perform because it'll get a bit long, but you should do really. We know it's a char star. Hey, Ma, look, I'm programming. Let's give it a scope. Non-void function has to return something. that represents a character, and it can't initialize it, so we are going to have a variable. We can call it anything we like. We should give it a default value. Can't initialize it like that. Okay. Do you need a scope for that? C++ doesn't allow the conversion. Of course it doesn't. Empty character string not allowed. So the answer is no. And of course we need a semicolon. Undefined or garbage value returned. Incompatible integer to pointer conversion. There you go. A character is a number. It's stored in memory as a number. The conversion it's talking about is the Ascii table, which is used for the keyboard. Each number from 0 to 255 represents something, including numbers and letters and pluses, minus, times, divide signs, all the rest of it. All of those possibilities. And there are 256 possibilities, 0 to 255. And those are the values of a char star. But a char star can't be stored in memory, so it has to convert it to an integer. To do that, the programming language can't do that. You would need a function or a module to do that for you. There are pre-written ones, obviously. You'll find those in the standard library or in the Qt library. But don't you think that's a little bit awkward? I just wanted to explain why it's 0 and not anything else. Good. Done. So we can now ask for the operation. Call the correct command for the operation. Now this is where it gets a little bit interesting, because now we can find out what our result is. Our result equals default. It's a const char star. That's a bad thing to do. Oh, it doesn't matter. Let's call it something different then. Calculate. We will need first integer, second integer, oh, did I do something wrong there? How have I spelt that? I put a U in it. Oops. That's another common problem, spelling mistakes. And we'll need the operation. So we can program it, sort of, we can split it down into modules of its own. Sub-modules, if you want to call it that. I don't care what you call them. And result is a char star. Is it? Yeah. So you're an integer, aren't you? Let's tell the computer that you're an integer. You're an integer, aren't you? And you're a char star. Oh look, we're using pointers. I can't see it all on the one line, so again, lines don't matter. It's where the semicolon is. Okay, I can do that. You don't have to make it look like that. You can keep it all on one line, I don't care. Take that off, do that. Char star calculation result equals default. I'm just going to use the word default because I don't care. And we can return that. So we've got a load of, what's this ISO one? ISO C++11 does not allow conversion from string literal to char star. So we can't make it equal that. There you go, corrected that. We now have everything we need for this module to work. Values stored to result is never what? Is never read. No? It is. Here. That's passed through, it's never read. Oh, okay. QInfo might not be the right function for displaying things. Okay, we'll have to do our own function for that. Fine. But it's telling you the truth. That's why I'm using Qt Creator, because it will tell me the truth. Whereas if I was to use Visual Studio, it wouldn't give this error. Because it's not an error, it's a warning. It's completely correct. Result is never read. All we do is we pass it through to another function. That's what these left arrows mean. It just means pass these values into that function. It's just a way of communicating from memory to other functions, just like you can do here, where you can pass these values into this function, but we've actually got them inside the brackets. You can do this, you don't need to use that, you can put that inside of the brackets. It's just a different way of doing it. But our function doesn't have this ability. This ability is programmed into this function. This is an ability, an additional ability that has been given to that function. So that's been programmed in. So the correct way of doing it in raw terms is here. And there's the function with all of its blah, blah, blah. So now we have our module complete. It's done, it's finished, it's programmed. And I haven't broken any rules. This module doesn't require anything else. Pass 1 code, complete, done. Oh, hello Poppy. Didn't realise you wanted to do that. Yeah. Okay, you want me like. 1 second. So there you go, there's your program. There's module 1. But you can see by writing module 1, we are going to require other modules. That's what I wanted to show you. That's why this is the start point. Even though your jigsaw puzzle started off with 2 pieces, your jigsaw puzzle now has main, which is 1, the second piece, 1, 2, 3, so second, third, fourth, fifth. It's now got 5 pieces. You've now got 5 pieces to your jigsaw puzzle. How big is your jigsaw puzzle gonna get? This is just one file that will deal with everything to do with module 1. These functions can be transferred to other files and included, obviously, just like module 1. But they'll need to be in the same namespace if you want it to continue. It needs to be under the same protection, or you could add an extra namespace and then an extra namespace, etc. on top. So you could have as many namespaces embedded within each other, all protected by scope. You can only go into and then come back out of scopes. And it's interesting how that all works. That is not covered in this module. Okay, that's everything correct. What we're going to do about these unused parameters. We'll use switch. Is it a bracket? I don't know. How do you use switch? I don't use switch. Ever. Scoped. It's got to be scoped. Expected brackets. Okay. There you go, there's some brackets for you. Alright, let's see how switch works. Statement requires expression of integer type. Jar star invalid. Okay. So we can't do that. Even though we know it's storing it as a number, the programming language, this raw programming language, is type defined. Do we have a static cast? Yes, we do. Well, I'm not going to use a static cast. I'm just going to say, treat it as an int. Cast from pointer. Good. Depointer it then. Told you we were using pointers and we hadn't spoken about it. So that's how you would get rid of that error. We would then have case plus I'm guessing that's going to have its own thing. Expected an expression. I don't know what the Ascii for plus is. Ascii table. Ascii table. Let's try and get a clear one, shall we? As you can see, 0. It's got all the numbers. Where's the plus sign? Ah, there it is. It's number 53. So that's what we want. Case 53. Guessing it's going to be brackets again, isn't it? Probably. There you go. Done. I can't read the number 53 and I'm not going to memorize it, so I'm going to tell myself what it means. Oh, you would do that. It still does that for some reason. Oh. Look at the errors coming up. There's 5 operations that we're going to do. Alt, Shift, drag. Yep, that looks better. I don't think the last one is a case. Is that not just default? Yeah, it is. Okay. That represents in Boolean algebra false. Good. So if we do nothing, it's going to return a value of 0, which is false. That's going to be handy, isn't it? So, plus, what's add? That is add. Subtract. God, this is horrible to read. That's an underscore. Where's subtract? Having difficulty seeing it. So it should be near the 53s. Doesn't seem to be. Alright. I'm dumb. I don't know where subtract went. Where's the minus key on the keyboard? Is he there at 176? Or is that a hyphen? 176 is the number for subtract. Interesting. I can't see it anywhere else. I'm going to get this wrong, aren't I? I think it's that one there. I think it's 55, but I can't see it properly. Can I blow this up? Ooh, that looks bad. That's very useful, isn't it? Where's the lock the alpha channel? Lock position and size. Background. Where's the background? Remove alpha channel. Ah, thank you. Ah, you beautiful thing. How do we zoom in and out? Plus and minus. That's an easy way of doing things. Still very difficult to see, isn't it? It's not very good definition. Stuff it. I'm going to ask the computer what it is. That's not helping. We need to ask the computer what it is. Oh. Need to change the values, otherwise it won't compile. We'll just guess. Compile it. Unused, yeah. Yeah, that compiled. Good. Subtract. Yeah, you can ask the computer. There's no harm in that. There's the subtract key. Let's try that. Subtract equals minus. Very funny. I like it when you get comical like that, computer. 45. There's your answer. Subtract equals 45. I didn't really want to get it wrong, so... Alright, I want to keep that. Let's get rid of that code. So subtract equals 45. We now know the answer to that. Multiply. We may as well keep this going, actually. We'll ask the computer what the blooming answer is. Multiply. We can use the asterisk for that, can't we? Yeah, why not? Is 42. That's an interesting answer. And that's plus. Should we have minus instead? That's subtract, multiply, divide. That was the one I'm missing. Let's do that. So divide. What's the division key? Is it that one? Yeah, it says. That's what's on the keypad anyway. So just run that. And that's 47. Thank you. So there's your numbers. We don't need this anymore. So to add, this is where it gets complicated. Calculation result. We don't need calculation result. That's irrelevant. Because we set it to 0. So we can return first integer plus second integer. Oh, what's wrong with your casting? Cast to char star from smaller integer type. Yes, you're right. Okay. This means we've got our types wrong. So let's start back here. We don't need to be constant. Integer result. Result equals default. That now equals 0. Blah 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 blah. First, second. The result is now incorrect. Okay. That becomes an integer. I was doing it as a char star because I wanted to make it generic if you really, really wanted to know. But it really doesn't matter that much. That's now an integer. We're starting to get rid of those red markers, aren't we? Yes, good. Ask for 2 integers, ask for the operation, we've done that. That now works. What are you talking about? A value stored to result is never read. Yes, we know that. We don't really need that anymore. We can just put equals 0. That gets rid of that error. Okay, how are we doing in here? And where's our yellowy bits? Okay. Matches. With the default there, it should never get to this line. That should be an error. It can't actually happen. It will never execute that line. Interesting. Well, return. This is the worst program I've ever written in my whole life, but it's probably the first program this is probably how I would have done it. The first time round I would have ever programmed it. It's the worst case scenario. And divide. I'm just trying to do it with as little code as possible. First integer divided by a second. So you can do maths, and it will go with the rules of maths, like division by 0 will give you an error. A big one. Might even crash the program. Because even us humans can't divide by 0. We've still got this marker. To get rid of those markers, I will place in things that won't happen. But it won't let me do it. I'm trying to do a catch-all. It did. Did it? Unused parameter. Okay. That's not the correct way of doing it. Let's see how badly I've done it so far. How badly have I programmed this so far? No, that's fine. Absolutely fine. So I've tricked the compiler. Yeah. These lines of code will never execute because the default will return 0. It will only ever get to that. That's the furthest you can go in this program. You can't get to that line there. That will initialize and call that. That will then call that, skipping those lines. That will then get you back into there. Great. So those are your callbacks, by the way, as well. So we've got the results. That all works. We've got a result coming back through. That should work. We can test it. No, don't put it there. Don't do that. That's bad. So blah 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 blah. Put it here. Test values. First integer equals 10's a nice number for base 10, isn't it? Second integer 2's a nice value doing easy maths, and operation equals plus. Okay. He's still not happy about me using that, and I don't know why. It's probably because it's not in the raw thing. So we'll try 53, shall we? I'll shut it up. Value stored to operation during its initialization is never read. Yes, we know that. Because we then go and do some test values on it. So 10 plus 2? 12? Might be helpful. Did we do that? We don't get this happening here. Something else is happening. So let's have a look under application. Crashed. So our raw code is incorrect. Why is that crashing, do you think? I did change them all over. Doesn't matter. First integer, operation. But I just hit debug, by the way, here. Result, second integer. We're running. We're on line 15 of module 1. One of these allows me to step over. Step over, thank you. Do the next line. Nothing's changed. Nothing's changed. First integer becomes 10. Second integer becomes 2. Operation becomes OX35. No! You would. 53 is that OX35. 3 times 16 is 48 plus 5, 53. Oh, so it's right. Good. OX35, that's in hexadecimal. I just had to do a quick calculation. Right, result. We can step into that, can't we? We're still running. You can see on the right hand side we're still running. Okay, that takes us to a switch operator. The inferior stopped because it received a signal from the operating system. Seg-v. Sig fault. Segmentation fault. That means we've just corrupted our memory. But where? That's an error? Wow, we turned it into an integer. And you can't do that, can you? So even though it's not an error, and it compiles, this is a memory corruption. What we are doing is we are taking the memory location of operation and we are changing its data type to an integer from a char star. A char star is 1 byte, an integer isn't. It's 4 bytes. And by doing so, we are claiming to use 3 more bytes than we're actually allowed to use. And that is memory corruption. So can we stop this now we've crashed it? Thank you. Interesting. So I've shown you memory corruption now. We're still getting that crash, are we? I need the value there. How do we get the value? Well, we can't, can we? Expression of integer type. Star, chart, star, invalid. What we need is that. I'm not writing this. It's already been written. Ascii to integer is a function provided not by the language but by the standard library. I've got a horrible feeling that this is going to cock up as well because we haven't included anything. Yeah, I agree. So what I'm asking for here is a standard library version of Ascii to integer. Simply put. Where's the home button gone? Oh, right, there you are. A to I. So it's int a to I, const char star. Oh, it's a const. Oops. My bad. A little bulb comes up because we've changed it. That will automatically change this one. That's fine. we should follow on with the correct things here as well. That really should be a const Shasta. Yeah, I've already done it. What's wrong with you? Alright, that should work there. What about here? Oh, we're actually making it here instead of at the top. Okay, that's fine then. That needs to be a const Shasta. Yeah. That might work now. We might have to change this to A plus. Incompatible. A plus. Now it works. Okay. All due to constness. And we haven't even gone near constness. That's constness and these pointers. It's a can of worms. I've now got to go through the whole thing for constness. I'm okay there. That could work. I don't know. I'm not a programmer. So, bear with me. The program worked and we got a result of 0. Wow. We got a result. Our first result, but is the result correct? No. Because we don't know what this is. It is 0. It's going through here. It's returning 0. So it's not catching these numbers here, is it? What is that doing? So let's ask the computer. I'm showing you how to learn how to program. I'm not a programmer, so I have to learn to program as I go. Oh, silence, sorry. I've been concentrating, haven't I? My bad. Sugar. Oh, bollocks. That's... You just distracted me. Sorry, I'll have to... Yeah. You're trying to help. Silent Z is telling you the problem is the fact that you are overwriting it before reading. Yes, that's correct. Operation is a pointer. You assigned it invalid address 53, which you later dereferenced in calculate. Correct, I did. Absolutely, you know what you're talking about. So this is how we could find out. But yes, you spot on. You've just jumped to the conclusion. What have we done here? So let's give ourselves some information. A to I evaluation equals something or other. So there we go. So yeah, this is for all levels of competency, from somebody who's never written a program to somebody who's written many programs. We'll pop you there. So I don't mind you putting that in chat. I think that's brilliant. I'm glad that somebody does do that, because you probably said it better than I could. In any way, shape or form. Yeah, ATOI evaluation equals 0. Oh, I see what you mean now. You're completely right, I just needed to... Operation is a memory location. Is that correct? Read-only variable, it's not assignable. Of course it's not. So do I have to dereference it? Yeah, I do. Is the answer. That line's wrong. I'm not very good at assigning const char stars. Never have been. Is it... on plus, don't I? Scoped. No. It's a string. That's a string. Is it scoped? Do I need it scoped? It's still giving me a 0. Okay. I'm assigning the memory. That's a single quote. Invalid conversion from char to const char star. Get rid of the constness now. Oh, we can't, can we? Yes, we can. We've overcomplicated it. The operation is now correct. Fantastic. We don't need that. We don't need that. We don't need that. We don't need that. We can double check that we do it correct here. We no longer need that. Interesting. And we no longer need that. We've just simplified it all. We can pass back by value. No, we can't, but we're going to do it anyway. No, it can equal 0, can't it? It's a value. Can I list? Get rid of that star. Yeah, that's starting to read right. And this is a simple program. I've still got an error here. Don't know if it is an error. Let's just do a build and find out. Looks okay to me. Result equals 0. That's good. Escape. giving us the right result anyway. Switch operation. What does operation now equal? Good question. Sorry, I'm just on the finals of getting me damn logic right, and I always have problems with this. There'll do. I'll hit the debug button again. I hate the debug button. 10. Operation is plus, which equals 43. I've got the wrong number, have I? Let's find out. Yes, you can do that. But we'll stop. We'll do it properly. There you go. That's correct. So the result of 10 plus 2 is 12. After taking out all of the garbage that I had put into it by accident by overthinking it. One of the problems is don't overthink your solution. And what I accidentally did was start assigning memory locations rather than assigning values to memory locations. Silent Z put it better, I think. Operation is a pointer. You assigned it invalid address 53. Pointer, the address on the computer, in the computer memory, address number 53 is non-accessible, or 0. It's no, we can't call it a null pointer, which you later dereference in the calculation. Correct. So instead of using a data value, I was trying to use calculations using the memory address. And because of these things called pointers, it's screwed up. Very much awareness has to be made. So I should be able to do 10 minus 2. 8. I'll go with that. I think it might be working. We should be able to do 10 times 2 with our newborn calculator. 20. I think I'll agree with that. And we should be able to do 10 divided by 2. 5. I'll agree with that. And we should be able to put 10 J2. 0. Well, that's correct. The mathematical operation J, 10 J2, is 0. Because it isn't a mathematical operation. Okay, so we know it's working. So we have one part working. Am I continuing with this, or have we got far enough? Do we really want to do input-output? Sorry, input, isn't it? So there's only input left. We've done the calculator, which is what I set out to do. And we've corrected it all to the correct raw code. Is this code still independent of operating system? Well, we're cheating on the output as well, but so we've done it. Module 1 now works. We haven't got input output. So probably Module 2 and Module 3. Module 2 would probably be input. Well, actually, no, you do Module 3 first, which would be output, obviously. Get rid of that Q info. Module 2 would be input. And our jigsaw would grow. And that's how you do modular development, because you can't do it any other way. People might argue, isn't that functional development? Well, like I said, an apple is a fruit, but not all fruit is an apple. It depends which way you look at it. It's your viewpoint. It's the same code, by the way, for object-oriented. It's just not called a namespace anymore. It's just called a class. It'll do exactly the same thing, using exactly the same code. The code's rubbish. It's pass 1. There's no error checking there. We're not checking if we're dividing by 0. And I wasn't going to show you that it would crash the program, because it does. I don't even need to show you that, because it's bloody obvious. You can't divide by 0. If the answer doesn't exist, then you can't do it. But that's how you program. You might be surprised to know that that is the first, no, actually probably the third program I've ever written with a switch statement in it. Anybody who's watched me program before knows that I don't use switch statements, and I don't use if statements. I do something else. I use Boolean calculations. I use Boolean maths to make my decisions for me. I'm not going to cover that here, because I think that goes beyond beginner. But that's your code. That's how it works. We do need to look at pointers and what they mean. Is it a complex issue? No. A pointer is a memory address. That's quite rightly pointed out by Silent Z in the comments, in the chat. Can you use memory addresses in the way which I just did? Yes, you can. You can use them within calculations. You can take the location of a memory, piece of memory. Doesn't matter what the data is inside the memory, but the location of that data, and you can do a calculation on that location and then retrieve the result or resulting data at the location that you calculate. That is called, oh, it used to be called vectors. I don't know what it's called now. Lists, maybe? Arrays? Do it? Iterators do it. It's what iterators are. Just advanced topics, really. There's nothing fancy going on. You're just manipulating the access to your data rather than the data itself. You can still retrieve the data and then act upon that piece of data separately, which is what I didn't do. I had that little star hanging around, that thing that says pointer or memory address. Call it pointer if you wish. I'll call it memory address. That's what that little star meant that I had to get rid of. The const char star is the equivalent to a string of characters, whereas a char is the 1 byte storage device for a single character. So it's all interesting stuff. So this language, this raw language, is very complicated. Yeah, there's very little in the blue. The actual language itself. The complexity of the language comes from what you do with it, which I find interesting. For a language that started off with 15 commands, you can do anything, absolutely anything on a computer. With those three basic, the three basic commands that I've used today, you can do mostly anything on a computer. You might want to go into advanced areas as you grow in confidence in programming, and I think I've covered most of the basic mistakes that people make. I'm hoping I have, but there's more basic mistakes that I haven't covered. Like learning to read an Ascii table. That might help me one day. Is this code any good? No. Could I do a pass 2 on it? No. Would it be worth doing? Yes. It's the perfect code. Am I allowed to do that? Decisions. What time are we on? 16:07, okay. We did start late, so we're only 3 hours in, but 3 hours might be enough for most people, I think. I think 3 hours is everything you need to know how to program your first module. And what happens, you then find you need to create other modules. And the only thing that I've done that is illegal is I used QInfo to help show the outputs. So you can't use QInfo, you have to take that straight out. That becomes pass 2 then. Pass 2 takes QInfo out, which would then force you to program module 3 output. So that's why I can't go to pass 2. I would have to complete pass 1. Oh well. There's your program. Can it repeat? Yeah. Just keep saying that running equals true, or delete the line. Delete the command, false. Yeah, deleted. That now repeats. That doesn't. What are these 2 slashes? Comments, things to ignore. The compiler will ignore this line. These are for us, the programmer. Comments are useful. Problem is, if you have to put comments in your program doesn't really explain itself, does it? That's the standard reference for that. shut down and clean up. The command we are using for shutdown and cleanup is a close bracket, because it is a command. It doesn't come up in blue though, which surprises me. As it is, in truth, a command. It does quite a lot. So I think I've covered everything that you can use within the programming environment, including outside libraries or functions. I could replace that with the standard cout, which is IOStream. So there is a standard library version of QInfo called IOStream, and that has the functions in for std cout. On the C standard library, there is also a library named stdio, which has printf, or print formatted, which automatically goes to the console if that is the currently identified output device. It defaults to the console, let's put it that way. So you could use printf. You can use any function that has been devised. qdebug, qinfo, is it data stream that it comes from this? qMessageLogger is the actual function that we're using, because qinfo is a macro. So there's macros as well. Macros are easy. No, not covering advanced. We're done. We completed module 1, made it work, got it working, and that will probably be the process of the first program you ever write. I had the advantage of knowing how to write a program initially, but I tried to make as many mistakes as or basic mistakes as I could. That file is correct, and this I've checked through now, it's correct. What do you do with this module? You save it, you keep it for your life, the lifetime of being a programmer. You keep revising, developing, changing, improving, evolving, not necessarily for the better. So it isn't improving, it is evolving. You evolve your code, for better or for worse. And over the years you learn, and you enter into more advanced techniques which would change this completely. You create your own libraries of these modules. This is all saved, isn't it? And you can come up with masses of modules. Libraries of modules with dealing with specific things like OpenGL. Are these modules any more complicated than the one I've just written? No. It's just the same. That's a function. Its own little separate module. All it does is asks the graphics card, that's defined by GL, OpenGL in this case, to bind a buffer. And it gives the parameters that the graphics card requires. That function is firmware on the graphics card. You can't change that function. The graphics card manufacturer can. It's called firmware. So these functions and modules that have been pre-written that you can include and use yourself can come from anywhere. Not just the internet, not just GitHub, but from the hardware itself. And that a couple of days ago somebody was asking me about the usage of a program, and I said I can't use it because it's got restrictions on it. And it was about GitHub, and it was a helper for writing programs, giving you ideas that these modules may already exist, or somebody may have already developed a module. Whether the module's good or bad is irrelevant. But the problem is not at this stage. Once you've got the hang of writing your own module and being a programmer, one of the major brick walls you're going to come up against is knowing what's out there. It's like, do you know off by heart every word in the dictionary? In the English language, do you know every single one of those 171,000 words? No, you don't. You have a capacity of knowledge, and you will use words within the knowledge and within what you think they mean. And you'll misuse words. And that's how you learn to program, in a modular way. What we've got left open here? I thought that was interesting. Ow, damn you. That's why I never keep it on big. Nearly went blind. You will close. So let's do the updates. Nerd fonts. Yay! Go you, nerds! Settings. layout switcher. Sounds interesting. So now you know why I'm not a programmer. Because every time I write a program, it's the first time I ever write it. I can't remember anything. Systems up to date. Okay. Fine. And it's why I'm a systems analyst and researcher. There you go. That's modular programming. Example 1, the calculator. Example 2 would probably be output. Maybe example 1 should have been output. Who knows? But it wouldn't have shown what I had to show. This is from first principles, by the way. There you go. But that might not be where you want to take your program. So it's 3 question marks. You may have predefined inputs. And the output may be to another part of your program. So example 2 and example 3 are so infinitely changeable that it's 3 question marks, which means they don't exist. Example 2 and example 3, they can't exist. Because there's an infinite variation depending on the outcome of example 1. Your example 1, not mine. But that's where you start your program. That's how you start programming. You start by doing that central core calculation. And your program will grow from there. Probably exponentially if you're unlucky. Because that's the rabbit hole. Journey down that rabbit hole, you'll never finish your program. Find the edges of your jigsaw puzzle. Find out where your edge pieces are and follow them. Start with that center piece. Oh yes, please do. But then go out in one direction only. Left, right, up or down. Find the pieces that join to that centerpiece. Find out where the edge is. And then go round the edge. And then complete the center. Don't go spaghetti on me. Don't jump down the rabbit hole. Don't lose sight of the boundary. Don't lose sight of the edge. Once you can define the central calculator, and from there extrapolate out to the edge, and then write all the modules that go round the edge, you can write all of the modules in the center completely simply. In very, very simple, non-error, non-bugged code. You will be able to do a pass 1, a pass 2, and a pass 3. you will have perfect code that doesn't have bugs, that doesn't have errors. And I can tell you from personal experience that it's damned hard to do. And the more intelligent a person is who wants to program, the harder it becomes. It isn't going to be a genius that makes that explosive next-gen program. It's going to be Joe Bloggs from down the pub on the back of a napkin one night whilst drinking beer. That's who's going to write that explosive, revolutionary program. Not Einstein. I think I finished. It's 16:25 and I do have to go and do that bank thing. So I'm done. I hope I kept to the point. Ish. Nearly. Sort of. It wasn't exactly a straight line. Oh, I can get rid of this now. But I have to get the cat out of the way. It's alright, Poppy, I'm not moving you. There we go, the keyboard slides out of the way of me and the cat. That's good. And we're left with a keyboard with the controllers on it. Stop streaming. So, that was it. That's how you do modular programming. That's why you do modular programming, because you have to. Just because people will call things by other names, that's not how you're programming. Don't be fooled by people coming along and saying, this is the new best way of programming. No, it's just a subcategory of the way you have to program. Bear that in mind. Take care. Enjoy programming. Play with it. Go have fun with it. Develop your modules. And one day, down the pub, drinking your beer on the back of a napkin, you'll write 3 lines of code which will change the world. Have fun.